Good morning. Welcome back. So I'm restarting these morning broadcasts where I solve SAT problems from the Khan Academy website live. So this is a live stream. If you're awake right now, you can tune in live. If not, you can always check these out later. And again, I'm going through systematically one by one every single Khan Academy section. And so now we're moved on to some of the more advanced topics, which include quadratic equations, which is really fun. I actually have a song all about the quadratic formula. You should check it out on my YouTube channel. And if you're watching here on Instagram, you won't be able to see the screen share. You won't be able to see me actually solving the problems. You'll just kind of hear me talking through them. So if you actually want to check that out, go to my YouTube channel. Just go to YouTube, search for Scalar Learning, and you can find this video. Again, it's entitled SAT Khan Academy Solving Quadratic Equations. Okay, let's get going right off the bat. So I'm going to do a screen share up here for you guys. Boom, we're in there. All right, let's begin. So take a nice screenshot of this. Let's go here. And again, as I say, it is always true. I'm not looking at these problems ahead of time, so I'm solving them live on camera. I think it makes it more fun. It does open up the possibility for me to not be totally perfect. I think, made a mistake 2 times, so that can always be fun. Anyways, let's begin. Okay, so we're just saying, what are the solutions to the equation above? What makes this a quadratic equation, by the way, is there's an exponent, something to the second power. Whenever you have the highest power be squared to the second power, it's quadratic. So how will we solve something like this? You got to recognize that this is a difference of squares. Let me change the cursor size. A difference of squares can be factored in the following way. So this is like a squared minus b squared. 100 would be our a squared. 121k squared is our b squared. So the way you do it is it's kind of like whatever multiplies to be 100 over here, that's our a, 10 times 10. And then whatever multiplies to 121k squared would be here. Now, the square root of 121 is 11. Square root of k is k. So we go like this. Oops. Hold on. 11k. Okay, so now we have it, but then the difference of squares means one is being added, one's being subtracted. Now, if you actually FOILed this out and multiplied it out, you would get 100 minus 121k squared because the inside terms cancel out with this plus and minus. So hopefully with enough practice, you can recognize that if you have anything like this, if you have anything like a squared minus b squared, it always factors to a plus b times a minus b. That's all we did here. And this whole thing equals 0, by the way. So that means that each one of these, so that means 10 plus 11k equals 0. 10 minus 11k equals 0. So we can just isolate each one of these. So let's do this bottom one first since it's down here. We're going to subtract 10 from both sides. We've got negative 11k equals negative 10. And then we divide both sides by negative 11, divide both sides by negative 11. K equals 10 over 11. Now that's one solution, but you can kind of see that there's going to be 2 solutions. I'm already going to cross off A and C because we've got a second equation that we have to evaluate here. So 10 over 11, you can actually already eliminate B because B doesn't even have 10 over 11, but let me just show you how this breaks down. So we have 10 plus 11k equals 0. Subtract 10 from both sides. Then we get 11k equals negative 10. And we divide both sides by 11. And we get k equals negative 10 over 11. So our answer is going to be D. Let's go ahead and put that in. Make sure we got that right. And we're good. All right, cool. Let's go on to question number 2. Here we go. Quadratic equations are one of my favorite types of problems to solve. I love factoring. I just find it, I don't know, find it fun. Okay, here we go. Number 2, let x equal a and x equal b be the solutions to the equation above. What is the value of negative a minus b? It just means we got to solve for this. Now remember, when we have it already nicely factored, man, they've done the hard work for us, because we can basically say like each one of these equals 0, right? Because if this whole thing is equaling 0, as long as one of these two pieces equals 0, it's going to multiply the other piece, because 0 times anything is 0. So we set up two different equations again. 2x minus 3 equals 0, and then x plus 4 equals 0. This one's pretty quick. We subtract 4 from both sides, and we get x equals negative 4. So that might be our b value. Let's just pretend that. And it doesn't matter which one's which. Then this one, let's add 3 to both sides. We get 2x equals 3. And then we divide both sides by 2. And we got x equals 3 over 2. So these are our two solutions. So again, it doesn't matter. We're taking the negative of this and the negative of this, which is right here, and combining them. So it becomes negative 3/2 plus 4, because we're adding a negative. We're putting a negative on that negative 4. So this is really 1.5. So this becomes 2.5. Why I kind of did that mentally. Let's reduce this to negative 1.5, right? If we make that a mixed number. So you can see this is really 4 minus 1.5, which gives you 2.5. But we're going to represent this probably as a decimal. So I'm going to represent this in the answer as 2.5. You should be able to also represent it as 5 over 2. It doesn't matter, but I'm just going to do it that way. We're good. All right, let's move on to the next question. 3 to go. Let's clear the board here. Let's check out this one. Again, if you guys are watching on Instagram, if you want to see the actual problems that I'm solving, go to my YouTube channel at Scalar Learning. Just go to YouTube, search for Scalar Learning, and you can see it's a live stream. It's happening right now, and you can actually see the screen share. All right, again, we have 0 equals 2y minus 1 times 8 minus y. So again, they factored it. This is just like that last one. We got to solve for our two values for this equation, and they've done all the hard factoring work for us, so that's pretty good. And which one is u, which one is d, again, doesn't matter, because we're just multiplying them. So let's set it up here like this. 2y minus 1 equals 0, and 8 minus y equals 0. Let's add 1, add 1 to both sides. We got 2y equals 1, divide by 2, divide by 2. Y equals 1/2. Let's take this one, let's subtract 8 from both sides. We got negative y equals negative 8. Multiply both sides by negative 1, we got y equals 8. So 1/2, and now they just want us to multiply these guys. What's 1/2 times 8? It's just going to be 4. Right, 1/2 of 8 is 4. So let's go ahead and see if that, make sure that it's absolutely right. And we are good. All right, 2 more. So let's load this one up here. These haven't used the quadratic formula at all. This is mostly just good old factoring. This is faster. All right, similar. In the equation above, m is a constant. If the equation has the following solutions, and they give us the two solutions, what is the value of m? Now it reads 2x plus 5, right, in parentheses, times negative mx plus 9, also in parentheses. Now this is really interesting, because we basically have to find our value of m that's going to satisfy this. This is how I'm going to run this as a shortcut. I see that this one solution is negative. And guess what? Right here, for this guy on the left, we have to have a negative 0. That's the only way we're going to get that quantity to become 0. This one, however, on the right is going to require a positive number, because we already got a negative sign in that first quantity. So this is just going to be a positive 3/2, probably is going to go here. So we're not worried about this, because we're trying to find m. So let's go ahead and bring this back here. Mx plus 9 equals 0. Now again, I've made that assumption that this value is the 0 over here. And I can kind of tell like that has to be true. If you want, you can plug in -5/2 over here and see it will go to 0. -5/2 times 2 is -5. But you can also make that assumption without even doing that arithmetic. So now let's go ahead and plug in our 3/2. We have -m. See, this is just another variable isolation problem. We're plugging in the x value because this is our 0 value. This is what the value of x that will make this one go to 0. And then all we have to do now, once we have all this in, is we just got to solve for m. They just want to know the value of m. So let's subtract 9 from both sides, excuse me. Now we've got -m times 3/2 equals -9. Now here's what I'm going to do. To get rid of the negative and the 3/2 in one turn, I'm going to multiply this entire side by the negative reciprocal, or by the reciprocal, excuse me, because this will make that m positive and also get rid of the 3/2, right? These guys multiply to become 1. Get rid of that too. What's -2/3 of -9? That's actually 6. Okay, 2/3 of 9 is 6. -2/3 of -9 is 6. So we'll go ahead and enter that over here. All right, cool. We got it correct. Last one. Oh, this is a no calculator one. Oh, the other one was also no calculator. I didn't see that. Good. We're not using the calculator anyways. Let's do final one, and then I got to get ready and get out of here. So we have, how many distinct real solutions does the equation above have? All right. This is, again, this is a difference of squares. It's already factored. What does that mean, distinct real solutions? We're trying to find, again, we have x plus 13/2 times x minus 13/2. We're trying to figure out what's two values, or values, whatever, we don't know, will make this thing go to 0. Well, because it's factored like this, and we got two different things, we got x plus 13/2, x minus 13/2. What's going to make this left side go to 0 is when x is -13/2. That's one solution. The other solution, when this guy goes to 0, is positive 13/2. But they're not even asking that, and I think they're trying to be a little confusing in case people don't know what is a real solution. Real solution is just a solution that's a real number. That's it. -13/2 and 13/2, both real solutions. Therefore, we got 2. And a quadratic equation, at most, you're going to have 2 real solutions. You can either have 2 real solutions, you can have 1, or you can have 0. But when you have 0 real solutions, you will have imaginary solutions, but that's for another time. All right, so let's go ahead and enter 2, make sure that's correct, make sure I didn't miss anything, and we're good. All right, so there you have it. Let me go back and stop the screen share here. Okay, so that's it. Thanks, guys, for joining. Hope that was helpful. Again, if you have any questions or comments, feel free to leave them below, and hope this was helpful for you. If you want to also check out my SAT course on Udemy, you can always do that as well. It's a full-length SAT course with loads of practice problems as well for you to check out. Thank you, guys, and have a great day.